All right, I'm going to do a quick demonstration of how to do an entity relationship diagram. And so I'm going to use a piece of software that is available to students for free called Lucidchart. So if you go out and Google Lucidchart for students, click on the link here. And there's instructions here for how you can sign up for an education account. Okay. No credit card required. You'll end up with a diagramming tool that is pretty handy. Right. So let me go ahead and open mine up. And I'll show you how to do this. Now, if you're doing the database design homework, you can either do this in software like this, or you can do it on a piece of paper, hand drawing it. But the basic concept is the same. Okay. So I go out here, and once this loads, I have a ER diagram right here that I created a while back. And so Lucidchart has symbols to help facilitate making your ER diagram make it a little bit easier. You've got these shapes right here. Okay. You'll notice that I'm using a 3-column version in my example, but you can do a 2-column, doesn't really matter. Okay. And you just drag these over to the palette here. Okay. Now I have a few here in place. So this is aligned with what you're doing in the homework assignment for those who choose to do the database design. You're going to have tables. So for an example, I have student table, I have a ticket table, and I have a ticket code table. Okay. And then within each one of these, I have my attributes here. Okay. These would become columns in an actual database design. So this is the data. This is when we're doing the ER diagram to do data modeling. Once we do design, these become the column names. Now the relationships, this is the part I wanted to show you today. So when we build a relationship between these tables, we can draw a line. Okay? And so to do that, I just click here and I choose another table. And we're just going to do one here to show you what this looks like. It has some symbols already on it. You don't need to go and manually create this stuff. This is why I like tooling. This tooling has different symbols here that we can use. Okay? Now we need to calculate the maximum cardinality and the minimum cardinality. So I'm going to go ahead and, for the sake of showing this to you, I'm going to clear this out to say none for both, okay, on both sides. First, we're going to look at student and ticket code. Okay. Now, the reality is there's no relationship directly between student and ticket code. Okay. So this line here, we wouldn't actually put a line between student and ticket code. So we're going to go ahead and get rid of that. What we're going to do is we're going to go ahead and take and recreate this line here. Okay. So we've got our student, and student can relate to tickets. We have tickets, which relate to ticket codes. Okay. There's no direct relationship between a ticket code and a student. Okay. So if we have a student, they can receive a ticket. So we go over here, okay, and we're going to clear these out just temporarily, just so I can illustrate this. Okay. So now we've just got a simple line. Now, what are the minimum number of tickets that a student can have? Well, a student could have no tickets. Okay. So we're going to go ahead and say that the minimum is 0. Okay, so 0, remember, is going to be the O symbol here. Now we need to calculate maximum cardinality. Okay, so that's minimum. Now, what are the maximum number of tickets that a student can have? Do they have a maximum of only 1 ticket or a maximum of many tickets? Well, they can have a maximum of many tickets. So we want a crow's foot. When we put the minimum and the maximum together, we end up with 2 symbols in that line. Okay. So minimum cardinality was a 0 or an O, and the maximum is there can be many tickets. So we use the crow's foot. So it looks like this. So a student, their relationship with a ticket is that they don't have to have a minimum number of tickets because they can have 0 tickets, but they can also have many tickets as a maximum number of tickets, okay? So we show that the cardinality for a student is a circle and a crow's foot to that ticket table. Now we go the reverse. We look at ticket and we go to the left and we look at the relationship with students. So a particular ticket, can a ticket be associated with multiple, sorry, let me rephrase that. What's the minimum number of students that a ticket must be associated with? Well, if you have a ticket, let's put aside faculty for now, we're not talking about faculty. If you have a ticket, what's the minimum number of students can be associated with a ticket? And the answer is 1. A ticket has to be associated with at least 1 student. So for the other direction in this line, we know that we're going to at least have a line for the minimum cardinality. Now we go and say, what's the maximum cardinality? So what is the maximum number of students that a particular ticket can be associated with? And the maximum is 1 student. We only have the capability for 1 student. So we go and find the symbol here with 2 lines. Okay? This shows our minimum cardinality and our maximum cardinality. Okay? So we can now see if we put that together, a student is associated and has a relationship with the ticket table. Okay? With respect to a specific student, a student does not have to have a ticket, so that's the 0 here, but there can be a maximum of many tickets for a student. Okay, so you can go park in the no parking space, 100 times. That's many. Okay, so the relationship between student and ticket is a minimum of 0 and a maximum of many. Okay. Now, if we look at the reverse, a ticket relationship with a student, a ticket must be associated with at least 1 student, and it can be only associated with 1 student. Okay. So we have 2 lines that indicates your minimum is 1 and your maximum is 1. Okay. Now let's look at ticket and ticket code. Okay. So a ticket has a code of what kind of ticket it is. So did you park in a disabled space? Did you park in a red permit zone, but you only had a gold permit, etc. Okay? There'll be different ticket codes, and each one of those ticket codes will have its own fine associated with it. So we don't capture the fine in the ticket table. We capture the fine in the ticket code table. Okay? So what's the relationship between the ticket table and the ticket code table? Let's draw that out. So we've got a line here, and again, we're just going to go ahead and 0 it out so it has nothing in it to start off with. Avoid confusion. Okay. We've cleared that out, and we clear this one out. All right, so now a ticket, what's the minimum number of ticket codes on a ticket? Well, if you have a ticket, it has to have at least 1 ticket code. Okay, so that would give us 1 line. Now, what's the maximum number of ticket codes per ticket? Well, a ticket can have multiple codes on it. So then it's a line and a crow's foot, because there's the minimum relationship, which is the line, must have 1. What's the maximum number of ticket codes on a ticket? You can have many ticket codes. I could be parking in a red space and I have a gold permit, and I'm parked in an EV space, which is only supposed to be for electric cars, and I am parked in a space that's marked as disabled as well. Okay, so I could have 3 ticket codes. All right. Now, from the other side, a ticket code, how is it related to a ticket? So a ticket code, what's the minimum number of tickets that a ticket code must be associated with? Well, we could have a situation where we have a ticket code that's never been associated with a ticket before, right? So in that case, we can say that there is a minimum of 0, okay? Now, what's the maximum number of tickets that a ticket code could be associated with? Well, there could be many. We could have 100,000 students who all do the same thing, okay? So that's a many relationship for maximum cardinality and a 0 relationship for minimum cardinality. Okay. And so that's how we do this in the Lucid Chart software here. This is how we define our cardinality. Now, after we've done a data model, we take this and we want to turn it into a database design. That's where we start doing things like this, where we create a table, and actually, let's do this. Let's take this. Okay. We create a table, and we'll say this one is the student table. Okay. And we say, oops, I picked the wrong symbol. This one here. Okay. So let's say this is the student table. Okay. And let's say we have student ID, last name, ticket number. Let me just make this abbreviated. Student ID is the unique identifier for the student table. That's our primary key. Okay. Student ID is an integer data type. Okay. Last name is not a key. Ticket number is a foreign key. Last name is a string or a bar card, depending on the database type that we're using. Okay. And then ticket number, again, is an int. Now, ticket number is a foreign key, and it points to the ticket table and the ticket number primary key. Okay. So we can visualize it this way. When we have a relationship, we can point to a specific piece in the database. So this effectively goes here. Don't need the symbols because we're doing a design now. So this shows a relationship. The foreign key ticket number points to the ticket table primary key. Okay. So that's what we could do when we're doing a design. We just basically take the same thing, go like this. We've got ticket. We have ticket number. We have date, and we have code. Now, this here would probably be a special data type. So now the relationships, we know that the primary key here is our primary key. There's no direct relationship, but we know this foreign key points to this primary key. We don't need these symbols when we're just talking about the design. We only use those for data modeling. Okay, so I'm just going to get rid of these symbols here. And then same with this table, we have a relationship with the last table, which is the ticket code table. And so we have the code and we have the fine. Okay. Oops. And we don't need this one anymore. So now we have a relationship between this foreign key, oops, and this primary key. Again, for the design portion, we don't need these codes. So on the top line, the top portion here, this is our data model diagram, or ER diagram. This shows our data model. This down here is our database design. Now, this is all that you're asked to do for that particular homework activity. So you're just going to go through and compile something similar to this. Now, what does this allow us to do? If we're using certain types of software, we can actually then take this and export to our database management system. And we can go ahead and create these tables, and this generates SQL for us. Now this here is actually not valid SQL because I'm just illustrating what this looks like. If I did a proper diagram, I put in all the different data types correctly, I could take this, spit it into a SQL application, and I could run this as SQL code and create a database using my diagram that I've created here. Okay. And depending on the vendor of the database that you choose, it looks a little differently. Okay. All right, so that is doing an ER diagram for databases.